Hey everyone, welcome back to Newegg TV. My name is Paul, and today, once again, we have the salacious JJ here from ASUS, and he's here to share with us lots of different stuff. Now, if you guys have been watching our Newegg TV YouTube channel, you probably noticed we've been posting a lot of videos lately, including several featuring the new ASUS line of Z87 motherboards. These are motherboards designed with the 1150 socket for Intel's 4th generation core processors, aka Haswell. Now we've shown you overviews of all the boards so far, and now we're getting into the actual features of the boards with some demonstrations. Today's video is going to be all about, well, two different things. One is AiSuite III, and that is the software you can see running back there. That's going to allow you to access the optimization features, both hardware and software based, that are integrated into these motherboards. And then a really cool feature of them, which is a one-click optimization option. It's called four-way optimization. We're going to get into that in a little bit, but for starters, we've got a Z87 Deluxe, which is one of the top-end motherboards from the mainstream series. We got that right here. So JJ, this is sort of the quick hit explanation of the four-way optimization here on the back. So what does this do, and where were you guys coming from when you designed it?
Pretty much, this is actually taking years of what we've developed within AiSuite as a whole and the kind of very exclusive and advanced level of functionality that we've been able to offer in such applications as FanExpert 2 or our auto-tuning technology or special EPU power management options. As great as all those functions were, what we've always strived to try to do when we have these type of applications is not just be able to actually provide you value and a benefit from that, it actually achieves what the end goal is in mind. Mm-hmm. So what we mean by that is if it's actually going to be a good automated overclocking utility, that it actually provides you a good quality overclock with efficiency and stability, or if it's power management, that it's not just something that's, you know, adding a small benefit, but actually an appreciable benefit, right, and helps to manage acoustics, or FanExpert, which makes the simplification of managing your system's acoustics as well as thermals significantly easier, right, based on your system configuration. So those are great, and we've had those now for a couple of generations in different forms, and they've evolved and they've improved considerably. But we've wanted to now consolidate them down and say, look, if you're looking for the easiest way to effectively overclock your system, manage your system thermals and your acoustics, be able to have optimizations in relation to power management, and be able to make all the adjustments that you need in terms of the power management configurations that apply to all those categories easily and effectively, let's do that for you in one simplified level of functionality, and that's going to be with four-way optimization.
So when you have a DIY builder putting together a system for this first time, this is kind of bridge that gap between I have my system together, up and running, to I want to optimize my system, taking into consideration both acoustics, power consumption, getting the maximum performance available, while at the same time maintaining a smaller power footprint, because that's more and more of a concern these days, is also maintaining, well, you want the speed of your computer, but you don't want to necessarily be running it full bore all the time. Sure. You want to be able to sort of dial things back when necessary so that you can save power and maybe save a little bit on your electric bill. Sure.
I mean, I think at the end of the day, all of us can appreciate that, you know, definitely do-it-yourself computers are targeted and kind of I think most received by enthusiasts, right, as a whole. So we tend to probably prefer performance, but I think at the same time, if we can realize that we can get good efficiency at the same time, why not take advantage of having, you know, lower power consumption, reduced thermal footprint, even the ability to extend the lifespan of that product, right? I mean, I think all of us can appreciate that type of design ethos. And I do want to touch on one thing, is that you did say kind of novice, and I think we're not just focusing four-way optimization at a novice. I think even seasoned veterans like myself, or even somebody like you know, we've given you the opportunity to check out four-way optimization, and you saw the auto overclocking results yourself. Yes. They're, I think, good enough that you could make an argument that even somebody that is very knowledgeable and experienced with their system is going to walk away with actually a system that's been configured and set up in a way that it's going to be hard to really kind of outdo it manually. Sure, if you were really willing to spend hours of time to be able to configure every single parameter, you could probably get a little bit more or have a little bit more tuned variability, and that's still going to be available to you, of course, via the software or the UEFI. But I think in terms of setting you a pretty great level of optimization right off the bat, it's going to be hard to beat.
So the minute tweaking still available there, but even if you're the hardest of the hardcore and you really like, I want full manual everything, if nothing else, this could give you a good jumping off point.
Sure, I think that's another great point to talk about, is that even for most of you guys, when you guys first set up the platform, you're not going to be like myself, where I've had the opportunity to test and tune over 80 different CPUs over months of time frames, over different boards with different solutions. I know the platforms inside and out, and I've had the opportunity to tweak them 4 ways till Sunday, right? Normal person, you're going to get this for the first time, set it up, and it's going to take you hours to try to figure out what the thermal characteristics are, what your voltage tables are, different thermal junctions, how this responds to this application, what each fan, what happens if you have 3 different vendors with 3 different fans installed in your system in different places. It's a lot of variables to account for, and here you could just click it once, allow it to go through its process complete, and you're going to get a pretty good baseline of what your system is capable of. And even if you then further want to define those things manually, you've at least got a kind of a perspective of where the performance can be.
All right, so we're going to show you guys the 4-way optimization, which is a one-click option. 4 elements that are sort of shown right here with the 4-way optimization. So can we sort of give a brief explanation of what each is?
Sure.
We'll start, how about TPU?
So TPU is kind of our hardware IC that we have on board that gives us advanced monitoring and voltage control, and that works in conjunction with our power delivery design, as well as the IVR, so that power regulation technology that's now built inside the CPU. So that's going to be the portion that's really focused at automated overclocking using our auto tuning technology to dynamically overclock both the memory as well as the CPU specific to your system configuration. So that means your power supply, your cooling, your specific setup.
All right, next up we have EPU.
So EPU, that's another hardware IC that we have, and both of those now come together to define our dual intelligent processors for technology. So that's a continual, ever-evolving kind of hardware that ASUS puts onto its motherboards that give us specialized levels of functionality. So the EPU function is about giving you flexibility at tuning your power management, and in the 4-way process it will tune down voltage as well as actually other variables to go ahead and bring down the TDP of the part, so you get better idle efficiency, lower power consumption, and it also works to adjust power for supplemental controllers that are on the motherboard, such as USB 3 ports or SATA ports. So if you have a device that says connected to them that are not reading and writing, it can actually turn off those ports and save you even additional power.
Very nice. So some extra power savings in there, and of course, it being a hardware base, it's going to work hand in hand with the TPU. Next up we have Fan Expert 2, and this is a software-based fan tuning utility. Is there a hardware element to this as well?
Yeah, definitely. It works with our hardware Super I/O controller that's on the motherboard that gives us all those advanced controls inside the UEFI, as well as gives us those controls with the operating system that we can further amp up on. And so this is pretty much just the ability for it to, per header on the motherboard, be able to adjust and ramp every single one of the fans, whether they're 3-pin or 4-pin, to their maximum values down to their minimum values, so that we understand how the fan works in relation to your system, while we're also running a thermal assessment. And this gives us the ability to kind of know that when we hit silent, we can actually have all the fans actually go down to 0 RPM and it's silent, because maybe you're just sitting idle at the desktop, or you're watching the latest video on Newegg TV, right? You don't need to have all the fans active. But then the moment that you decide to start gaming, if you wanted to, either the fans are going to ramp up based on the temperature being reported from the CPU, or if you want to, just click it onto silent or standard profile and it'll slightly bump them up. So it's a great way to automatically calibrate all the not only characteristics for your fan from a thermal standpoint, but also from an acoustic standpoint.
That explains why this fan to my left keeps spinning down to 0, but that's keeping it nice and quiet. We also have Digi Plus Power.
So power management options are kind of one of those things that we've had now for multiple generations, because we were leaders in implementing a digital power implementation on our motherboard. But not every user understands how to maybe maximize those settings to ensure that you're getting the best maybe efficiency or the best stability, especially as you overclock the platform. So this kind of links into the TPU, into the EPU elements, where we'll make adjustments to go ahead and maximize power adjustments for the motherboard in itself.
All right, so with that in mind, we're going to be giving a demonstration of the one-click 4-way optimization. Let me drop this down so you guys can get a look at the screen we have set up. So this is the AI3 suite software, and I'm sorry, AiSuite III software. And we're also going to be digging into the details of this, because this also gives you a lot of fine-grained tuning that you can do within your operating system for your motherboard and the hardware you have installed. But 4-way optimization, you've mentioned multiple times so far, is specific to the hardware and the system that you've put together. So with that in mind, we probably also want to give you guys a closer look up at this system we have just to the left, because it's pretty awesome. So let's take a look at that. Now this is a water-cooled system, of course, and we have several components from coolants. So we have the block, of course. You know what type of block that is, JJ?
Yeah, that's their high-performance current generation Intel water block. So that's the 380 series water block.
All right, and we also have an all-in-one unit that's actually up on top here. That's the radiator, reservoir, as well as the pump. And that is the EX2?
Yeah, that's the EX2 755. So this is a great unit, just keeping high performance, efficiency, having a lot of controls of both over the fans as well as the pump configuration. It goes really well with being able to take advantage of the fact that in this four-way optimization, it's going to be dependent on our cooling configuration. So since we got a water cooling kit here, it's going to allow us to go ahead and reach a higher clock speed.
All right, so water cooling, a great option for, well, any computer if you're into it, of course, but particularly for the new fourth generation core processors is going to, of course, allow you to maintain higher overclocks, and it's going to let you get a lot of performance out of your system. Now there at the back, we, of course, have the new ASUS Z87. Is this the Deluxe or the Deluxe Dual?
This is actually the Z87 Deluxe, and of course it features the new gold color ID, and of course rounding out part of the other water cooling aspect is that we have this beautiful Aurora Gold Mayhem's searing coolant that we have going through there. So you guys can see that it gives you this really just beautiful pearlescence gold that ties into the ID of the motherboard, I think, really nicely.
Matches beautifully. Also right here, you'll notice you have what looks like a fairly small video card. That's actually a GTX 670. This is the new DirectCU Mini GTX 670. So it's very suitable if you want to get a better look at your motherboard, or particularly for mini ITX systems. It's going to be a great.
Definitely. I think micro ATX, mini ATX, and even ATX, like you said, if you just wanted to be able to not necessarily have a large card and be able to maybe see more of the ID and the look of your system, the DC Mini is going to be a great card while still giving you a high level of performance.
All right. Powering our entire system, which is down here at the bottom. We have a Seasonic, this is the SS860 XP2, 80 plus platinum power supply.
That's right, yeah. It's a great PSU, fully modular, silent acoustics, great power implementation with exclusive power topology. I really like this PSU. Of course, it's powering a high performance system here. And
then for our memory as well as our SSDs, we have some parts from Kingston. So this is the Kingston HyperX Beast memory kit, and is this the 2133?
You got it. 2133 kits, of course, with the high performance heat spreaders on there, great validation testing. I think it goes optimally also with the focus that since we're going to have an overclock platform and our four-way optimization technology is going to be able to auto-tune to the XMP profile. Let's go ahead and take advantage of the memory. And of course, with the SSDs, we're running them in a RAID 0 configuration. And I love that the black aesthetic complements the board setup as well as the chassis, which, as you noted, I think you like this chassis as well.
It is a beautiful chassis. That's the BitPhoenix Ghost?
That's correct, BitPhoenix.
And then, of course, we also have ASUS Blu-ray burner.
Yep, it's actually a Blu-ray combo drive.
Blu-ray combo drive, I'm sorry.
Yep, because I'm, of course, a big fan of taking advantage of high-resolution, high-definition content, so Blu-ray is the best way to go in terms of that. So we've gone ahead and thrown that guy in there as well.
All right, so we have a complete system right here, and we're going to see how this performs with the four-way optimization. So now we've taken a look at the hardware, so we're loaded back up into Windows 8, and this is the ASUS AiSuite III. Now this is sort of the home base here. You got a little heads-up display, lots of information being displayed, and it seems like a nice change from what you've gone from with AiSuite II to AiSuite III. So we have sort of some quick hit looks at CPU frequency, voltage, temperatures. You got your fans right there, some quick buttons over there that you can access, EPU, TPU, Fan Expert 2, and Digi Plus Power Control, which all, of course, part of the four-way optimization.
Correct, yeah, and we even actually have DRAM frequency in there, and if you tap on that expanded button, you would actually even have, if we were running this with just the iGPU, we could get some other information. You can see that we give you real-time CPU usage. So overall, that primary screen focuses more on a consolidated level of overviewed information on how your system is set up and tuned and configured. And of course, when we go into more in depth on AiSuite III in itself, we'll talk about some of the really cool new functionality points that we have within AiSuite III as a whole. But I think from here, Mr. Paul, you're going to go ahead and execute
we're ready to click the big
optimization.
Button. And in case you guys are wondering, we've gone into the UEFI just before this. We set everything to factory defaults, or the optimized default settings. So
so we're running effectively stock.
All right. So clicking the big button, and we're going to see a quick notice. And what are we being
And so essentially here, it's just giving the option, if you want to run independent modules within the four-way optimization, you have the ability to do that. So if you click the advanced button for me, you can see that we have the TPU, the EPU, the fan, and then the Digi Plus Power Control options. So we can go ahead and just selectively pick each one of the ones that we want to go ahead and execute on. So for right now, because one of the biggest elements is going to be the auto-tuning technology, I think that's what we can focus in on. So if we wanted to, let's say you could go ahead and uncheck that. And we could leave the fan options enabled as well. And the Digi Plus power options are going to be inherently tied into that, so those are on as well.
Okay.
And it's really up to you in terms of how you want to figure that out. We'll go into a little bit more on how the EPU power management options work under our separate call out for AiSuite 3. So with that, let's go ahead and click the Start button.
All right, Start button. Quick little, do you want to continue? So it's going to give a restart now, and then this is going to start cycling through and basically automatically overclocking the system, sort of pushing it up a little bit at a time. And then what's it doing right now?
So actually, it's going to be making quite a number of changes in place. So the first thing it does is it actually applies a very small, basic preset overclock that we know that we've tested actually across our binning right now. At this point, I think we've done over 500 CPUs. So a lot of different CPUs, a lot of different actually analysis at seeing voltage tables, frequencies. So we start off with a small increment that we know is consistent across all CPUs. Once we've gone ahead and executed that, we're actually going to incrementally start increasing the multiplier, and which you actually have an option to. If you looked there within the options for in AiSuite 3 and the four-way optimization, we can allow it to go ahead and do the automated overclocking either with the BCLK or the multiplier. If we're going to go ahead and have him focus it on the multiplier, when it reboots, it'll start just increasing the multiplier, then increase the voltage that's associated with that multiplier, and then run a stability test. So we're going to go ahead and show a couple examples of this. So you can see right now it's gone ahead and applied a basic overclock of 4.3 gigahertz. Now, if you keep in mind that the baseline frequency is already 3.5 to 4.3, we've already made a huge increase in performance. So at this point, if you wanted to, you could actually stop the auto-tuning process from continuing any further and just keep this. So the process in itself will vary depending on your cooling solution. In most situations, it'll probably run somewhere between about, I'd say, 5 minutes to as much as about 9 minutes. And that'll just vary on depending on the cooling solution and the configurations that you're using in your system. But one of the changes that you're going to see as part of the automated auto-tuning process is going to be that we now have per core tuning. So before we used to dynamically raise all the cores, but in this generation we're actually taking advantage of something that's already been available in our UEFI or in our software, which is giving you the ability to do independent adjustments for different threads. So if we want to go ahead and have 2 cores for single thread and for 2 thread applications be set like, let's say 47, and then 4 cores set at another set of frequency, we can go ahead and do that. So right now you can see right here that it's actually running a stress test. If you want to go ahead and maybe right click and open our task manager, or I can go ahead and launch it either which way.
Task manager.
You can actually just right click here.
Oh, I know.
And so if you head over to the performance tab, so we can see right here it's actually running the stress test and it's dynamically occurring real time. So
CPU load jumping up right there. We can also see, of course, the memory and disk usage.
Correct, and right there it's actually, you see, focusing on the 2-core stress test, so it's ramping up, it ramped up the frequency for that, which is right now 44x for 2 cores, and then 43 for all 4 cores.
So we're going with 1 and 2 cores, you'll generally get a 100 megahertz boost at a time, and then we'll have the 3 and 4 core setting 100 megahertz below that. And then as it validates the overclock frequency for each one, then it'll bump up the 3 and 4 cores and then go back to 1 and 2.
So of course, and you can see the system working much harder there because now we're doing all 4 cores at 100% full load with our high integer-based stress test, which is actually very similar to very high load applications. So here we're intermittently testing each one of those. We're raising up the frequency and then raising up the corresponding voltage. It's pretty much the same thing you manually do when you're overclocking, right? You go in, you adjust, you know, your multiplier, you adjust your voltage, you then stress test it, it fails, and you keep going through that process. And that's what it's dynamically going through real time. It's just it's automated fully for you, and it's specific to your system and your configuration. So we can see here we've now gone up to 45x, and it's going to continue to be monitoring this. And one other thing that we do monitor is even the thermal characteristics, where it's actually going to be checking to see if the CPU frequency throttles, and that's what's going to be the ultimate rating factor on how fast we're going to go ahead and ramp up and how high we're going to ramp up in terms of the CPU frequency. So this will go ahead and continue on until we reach the final result.
And at this point we've gotten up to 45x on all 4 cores, and next up it will go to 46x on the 1 and 2 active cores.
Correct. And you know, depending, like I said, on your cooling configuration, even with our own, if we were to maybe increase the pump speed or the fan speed, then of course we could even get higher results. To keep things, I think, in conservative and to show you guys, you know, the most realistic system is we want to keep things as quiet as possible. So even with that high performance setup that we have there, we've set the pump speed to only 1 and the fan fan speed to 1 as well. So we're keeping this actually on the absolute minimum level of performance that that water cooling solution has to offer to us,
okay.
Which is still, of course, going to be significantly better than any air type configuration, but it's going to be the minimum heat dissipation capability of our setup.
Okay. Now, once this is run through and reached the maximum achievable overclock that the four-way optimization is able to achieve, are those settings then communicated with the UEFI and locked in?
Yes, that's correct. And so that's another kind of key aspect that you bring up, is that this hardware implementation is actually hardware-based as well as software-based. So we're working through multiple layers. Even though this is initially executed within the operating system environment, it's writing it directly to the UEFI, so it's occurring on quote-unquote a hardware level, because it's being written to the firmware, and the firmware is storing that information. So it's a full kind of 360-degree process of it doing the validation, the stability within the operating system environment, making the adjustments, all that is occurring real time and then going through. So as we can see there, eventually got to a point of instability, so the system gone ahead and crashed. We're acknowledging that crash, and we make adjustments for it. Even actually in the reboot countdown timer, we actually reduce the countdown timer to even be shorter than what it normally is. Normally it's 30 seconds, we actually have it adjust down, so you can see that it just continues to go through a much quicker reboot process so that it can continue the auto tuning process until it reaches a maximum voltage level. Now that's a key differential. When you generally go about manually overclocking your system, most people tend to use a manual vid, which is very inefficient. It means that you have a voltage fixed. Regardless if your CPU has the capability of going ahead and dropping down in terms of frequency and the voltage being supplied, you have people that use fixed multipliers with fixed voltages. That adds more voltage than you need to, adds a higher thermal load, produces hotter, consistent ambient temperatures, and you even have the possibility of having a higher likelihood of thermal degradation. And for us, we only use the adaptive voltage policy that's available that we've had previously as part of our digital power options. It is now also fully supported by the IVR, or the power regulation technology built inside the CPU. What that means is that the CPU voltage will dynamically scale down when the CPU frequency goes down, so we can keep great voltage efficiency, we can help to keep lower temperatures, reduce power consumption, and the voltage will only increase when the CPU frequency increases.
And manual voltage as well, you're pretty much negating all of the power saving and efficiency features that are built into the processor by default.
Correct, and there's no reason not to utilize them, because it doesn't affect our ability to have a higher overclock. So, you know, we go from the perspective that we're giving you the best of both worlds. Great efficiency, you know, with great power saving possibility, while also giving you an increased level of performance through overclocking. So the TPU technologies have gone ahead and executed their four-way optimization in terms of the auto tuning aspect. So now it's gone ahead and continued on to what would have been the EPU power management adjustment options, where it would have gone ahead and checked the power configuration settings we have, be able to bring down power consumption levels and turn off, like I said, supplemental controllers. And then from there, it would have gone into the next portion, which we're seeing right here, which is our Fan Expert 2 functionality. So this is actually ramping up all the fans in the system, which is why you heard them all get loud for a moment. And then from there, they're ramping back down. So that stores that information in the actual in the software to know which each fan executes in terms of its maximum RPM and its minimum RPM. So once that information is stored there, you can of course quickly go into the Fan Expert 2 software, and if you want to hit silent, then the fans will go to their minimum operating value, which is essentially off, so they'll really actually be silent. And when the CPU ramps up, you know, they'll be much more moderate and quiet, because they know exactly what the maximum ranges is of operation. And the same way, you could go ahead and set it to a standard profile to keep a kind of good balance of you know, improved thermal performance, right, but while still being moderately you know, quiet. And then you could, of course, go to higher performance by just disabling it outright, because it knows what the maximum value is. So overall, you're pretty much just automatically tuning your system and having that flexibility. And we'll touch on more of the fan control functionality once we actually get into AiSuite III.
What I've always liked about Fan Expert 2 is you can really just have like a hodgepodge of fans in your system. They can be 3-pin, they can be 4-pin. It doesn't really matter. It doesn't matter what vendor they come from. It goes in, it tests, sees maximum RPM, minimum RPM, and then you can adjust from there to get a suitable level of airflow as well as noise generation.
Yep, 100% right. And so the last portion is just a quick optimization to all the power management options. And we can see right here, it's gone ahead and completed our overclock. So we have a 4.7 gigahertz on 2 cores, and then 4.6 gigahertz on 4 cores. Now keep in mind that the frequency could actually even go higher than this if we increased what's our fixed voltage level. Now we've been very cautious that we still don't want to have an overzealous level of voltage that's being applied, even if that could give us more frequency. At the end of the day, it's very, very important to us that we give you safety, but high performance at the same time. So our fixed maximum voltage level is actually going to be 1.275 volts.
Okay.
We won't exceed that marker. Now, what is, though, something you need to keep in mind is that this is a preliminary version of the software. In the final version of the software, you're actually going to see a message that will pop up here within AiSuite 3 when it's completed that will tell you that once this is completed, if you decide that you want to additionally validate your system with some form of a stability test, such as Prime 95, OCCT, AIDA64, anything along those lines, because we are utilizing an adaptive voltage and changes within the IVR system inside the CPU, there will be a request to have an additional layer of voltage supplied on top of what we've already defined as being the maximum voltage table.
Okay.
So this is a very big thing that you do need to factor, because if your thermal solution does not have the headroom to compensate for this increased voltage, you will have a very, very high level of heat produced in a very small period of time that could induce throttling, as well as could cause even instability to your system. Now, for people that are going to use their system in a normal requisite, such as viewing videos, right, doing productivity or gaming, it's going to adhere to the voltage table that we've gone ahead and applied as our maximum. So I think we can actually show this through some real-world examples.
Okay.
So let's first up go ahead and maybe open up AIDA64.
All right.
So of course you could reference this information. We're going to keep this information report here in AiSuite open, but you could of course monitor CPU frequency and other aspects of this inside of our application, but we love AIDA64. It's a very in-depth application that gives us a lot of information. So let's go to the CPU ID tool, and this will give us some value. So we can see here one of the great things is that because of our use of adaptive voltage, the CPU frequency goes down when the system is under idle, right? And what does the CPU voltage do? It also goes down. So we're really getting that great power efficiency and that power reduction, as opposed to if you were doing it probably manual, you're going to force that CPU frequency to run always at that frequency, and the voltage tables are going to be significantly higher.
And that, as you mentioned, could even lead to CPU degradation over time?
Correct. I mean, it's always variable when you talk about overclocking as a whole, but if you can go ahead and achieve these same results without having to apply that high level of voltage always, you can really help to improve the overall lifespan of your CPU part.
That's usually the philosophy I go with. I want a nice, good overclock. I want it to be stable, and I want to use as little voltage as I can.
Correct. And I think that's where our automated technology really is actually quite good at giving you, 80 to 85 to 90% of really what you would be able to achieve, manually, right? So from here we have an idea of that. So what we can go ahead and do is let's maybe move this guy over here.
Alrighty.
And we're going to go to a pretty high load application, so something like Cinebench. Most users actually out there are never even going to be in this realm of usage. Most of us, when we work with our systems, we're generally doing maybe some basic photo editing. We're doing maybe some office productivity, typing some things up on YouTube. Maybe checking out Hulu Plus, listening to some streaming music. And of course gaming. But all those don't actually ever use the CPU from a high CPU utilization standpoint. In most situations, they're averaging maybe between 20 to about 45%, right? Maybe up to 60% if it's a very high load application. It's distributed out towards cores, but you generally don't have 100 peg CPU utilization. And this is where when we talk about stability testing should be applicable to how you use your system. If you're in a situation where you're doing a high level of consistent multi-thread 100% utilization, such as rendering, heavy audio and video editing, things along those lines, then of course you're probably going to be more matter about even overclocking at all, or if you are, you're going to want to focus in a different perspective, right? Where we of course have manual options that allow you to really fine-tune your system for that. So let's go ahead and take away the OpenGL, because we don't need to worry about that, because we don't want to check out the graphics card. So we can go ahead and first go to the multi-core render. So you can click on that guy right there. And this is going to go ahead and put the CPU under load. So if we check out our task manager again, we're going to see, of course, this information come up.
I think that's still over here. Oh wait, no, that's AiSuite.
Yeah, you can go ahead and just open it up right there. And just click on the Performance tab. Okay, and so we can see that's at 100% utilization. Now you've kind of covered up the AIDA there. So we want to check out actually the CPU frequency information. So we can see we've got our 4.6 gigahertz overclock, and we're actually at 1.245 volts, right?
Very nice.
So that's great. We've got a great sense of thermal efficiency. Everything's working well. It's gone ahead and ramped up. We got the frequency that we went ahead and wanted. And if we go ahead and run single thread, And the Intel Turbo technology based on temperatures and other factors is going to go ahead and also allow us to take advantage of that per core tuning that we went ahead and set on 4.7 gigahertz. So you can see right there it already had started at 4.7, and it'll go kind of up and down depending on, like I said, the thermal characteristics of what's reported by the sensors inside the package.
Okay.
But you can see right there it's at 4.7, and the CPU free voltage is actually sometimes even floating a little bit up and down because of course it's not driving all 4 cores. So we're able to maximize and give you that much better performance. Now we won't let it go ahead and complete the entire run of this, but what we're then next going to show here is going to be some variability that if you're going to really focus on stress testing, a characteristic that you do need to keep in mind is going to be that voltage increase that's going to happen because of the adaptive voltage. So from here, if we want to go ahead and launch the stability test with an ADA, we can go over into Tools, and then Stability Test. We can go ahead and hit Start. You're going to see that it actually jumps up to a very high voltage marker. And you see actually it almost even got to a throttle point because it reached a peak voltage, excuse me, a peak temperature that was over the thermal junction. For a moment, this CPU platform we'll talk more about within the overclocking guide has some variability in it. If we actually go to our statistic values and we look at actually our average temperatures, we're not going to be at that point. We can see here that the maximums jumped up to 98, 93, 93, 86, but our averages over time are actually going to be significantly lower because if we look at the average DTS temperatures, which if you want to go to the sensor tab in ADA, we'll see what our real temperatures are at, even at these higher voltages. We can go ahead and click on that tab right there. Just click on the little triangle, and then sensors right there. And we can see our actual temperatures are reported to us right here. And these are actually going to jump up and down quite a bit because of the internal design of the CPU platform and the fact that the DTS sensors are not designed for accurate thermal detection, but to monitor throttling. There's a very big difference between accurate temperature monitoring and monitoring for throttling, that there's going to be variance. Plus, because the CPU is executing other functions such as switching frequency for the internal IVR and other variables, these numbers are going to jump up and down, actually to fairly large deltas. And because of that, you need to be able to compensate that with a good thermal solution. But that's where we were talking to you about these. You can see right here, now the voltage is dropping down because at some points we're now hitting a throttle point. Because even with that solution, we cannot control that. We can't control that high level voltage. So this is where we really stress and advocate that if you're going to focus in on a manual stress testing application, you're going to want to go in a different direction, which it might be to manually tune your voltage, but you're going to be compromising the overall better efficiency, the lower power consumption, and the extended lifespan. So this is part of the reason why we choose an adaptive voltage, because we can give you that high level of performance that is going to work for 95% of you guys, because when you're setting up a system and you're running it, you're running your CPU 100% of the time. So we can go ahead and quit out of the stress test, because we can still see it's still holding, but of course the temperatures are getting to a very high point. And we can also see there under the memory type that it has gone ahead and also overclocked our CPU, overclocked our DRAM. So that Kingston HyperX kit that we've got in there, we've actually been able to take advantage of it, and instead of running it at the default 1333, which is what it would have posted at and been running at, we not only overclocked the CPU, but we overclocked the memory as well.
All right, so the system with essentially one click of the button running through all those tests is going to set you up right here. And then again, guys, if you're going to be validating your overclocks, just as JJ mentioned, a lot of these synthetic tests that you might run, such as Prime 95, such as the load test that we just set up right now, they're going to basically make the CPU behave in a way that you would never see otherwise. So would you recommend in that case more actual use case scenarios, run games, run applications that you'd run on
run whatever you're actually going to run. I mean, if you really want to run something that also is going to check your entire system, I've always advocated, regardless of the platform, you can use general synthetics such as PassMark performance tests, PC Mark. They're great because they're going to put your system through a high level of stress, and they're going to actually access the memory bus, the SATA bus, the CPU, the graphics bus, and even run them in tandem. A lot of stress tests, with the exception of ADA, do not tax the entire system bus. This is very important because overclocks affect all the system bus, and sometimes you can pass quote-unquote high-level stability tests, and the moment you start gaming or the moment you start to pass data through maybe the memory or through the SATA bus at the same time, you could still have a crash because you actually haven't tested for full system stability. And this is why it's important, run what you actually decide that you're going to be running when you use your system. And secondary to that, if you want to supplement it with actual performance-oriented testing, then you actually use something like I said, like PassMark performance tests. They're burn Run-in test is also a good thing because it runs multiple things such as video decoding, CPU load, memory load, and a lot of other variables that come into play.
Okay, so some important things to keep in mind there, and guys, if you are very curious about these types of overclocking questions, whether you're talking about load testing, whether you're talking about use case scenarios, we are going to have an additional video that's dedicated to overclocking more in a manual type configuration, so check that video out as well if you'd like some more information. For our purposes here, I think we're going to jump back to AiSuite III so we can dig into a few more of the more granular settings, you might say.
And so the last page, actually, we've gone ahead and moved off to it. But that also then, if you scrolled it down, would have given you the complete four-way assessment report.
Okay.
Broken down to let us know what the CPU frequency was, the EPU section in terms of if we reduce the power management, what wattage would have been brought down to from the CPU. So it could have been like it's recommending 20 watts that we can operate the CPU at. So at a lower voltage when you're maybe just doing a light load or you're at an idle state, as well as, of course, the fan expert. It would have given you the report and the assessment on that. And then lastly, of course, the power management options.
Okay, so sorry I clicked through that too quickly.
No worries. So from here, of course, we can focus on four-way. So, you know, just a recap of what we have here, as you noted on, is that we have kind of the primary HUD screen, which you can see right here. Gives us a lot of great data and information real-time available to us, such as even wattage for the CPU, our frequency. We can adjust per cores. We can see the loading balance, the load balancing. We can see our DRAM frequency adjustment, all our primary voltages, the temperature data. Now, for some people, they always wonder how we actually assess our temperature data. One very important point to note is that we do not use the standard DTS sensors that are inside the CPU. We actually have a thermosistor underneath the CPU socket. And that actually will read the ambient temperature there as reported, and then we offset a temperature that's reported by the CPU and the TCAS. The TCAS is, there's a difference in the temperature from the plating that's on top of the actual die for the CPU package. And then we create an offset and we provide you that composite average. So it's a much more realistic temperature of what your CPU package is actually running at. Now, if you want to, of course, you could still use a utility to assess the DTS values. But once again, you know, we want to touch on the fact DTS temperatures are not actually super accurate. They're a representation of what the temperature is internally, but they're also more present there for throttle management than they are for full accurate assessment of temperatures. So that's just something to kind of keep in mind, and that's also why there's sometimes a slight differentiation between our temperatures and the DTS temperatures that are reported. Of course, you can see motherboard temperatures, and then you can see all your fan speeds. And if you click on the little gears icon, of course, that allows you to make a number of different configurations on thermal thresholds, temperatures, and other values that you want to go ahead and be able to adjust or configure for your system. So you got a lot of flexibility in this new persistent section of AiSuite III, where you can consistently see all this information regardless of wherever you navigate within the application itself.
Yeah, I like how you can get pretty much still the whole application there, and then you can come down here to adjust your settings.
Yeah, so if we go ahead and just click back, we go back to our primary screen, we can go ahead and head, let's say, over to the TPU section.
TPU.
So with TPU, this little delay right there, it's important to know that the reason why that occurs is there's polling. We're actually re-polling all the hardware to get a real-time assessment of that information. So at this point, you can see we have a huge amount of tweaking available to you. So you've got BCLK frequency, you got ratio adjustment, and CPU cache ratio. We're not going to get into exactly what all those cover because we'll cover that in the overclocking section. But these are all fully adjustable. You can independently adjust each core if you want to, or you can go ahead and set group tuning, which will allow you to overclock all the cores in unison. So as opposed to right now where we have 4.7 on 2 cores and 4.6 on 4 cores, you could go to group tuning and make them all go to 4.7 if you wanted to. So you got a lot of flexibility there in terms of how you set that up. Here you can see that we have the voltages corresponding to, of course, our adjustments for the primary CPU value. One really cool function now that we've introduced though for AiSuite III is if you want to go ahead and click into that little box.
This little box?
Yeah, if you want to, you can set it to manual. And you can click into that box right there, and you can now see that I now have direct key in. So I can key in, you know, whatever I want. So we now have manual entry built into AiSuite III. Previously, before, you only had the ability to use a slider to actually slide and adjust your voltages. So this is now even a kind of more intuitive and easy way to be able to adjust and make your value assessment. And you can also see that we've color-coded this as well so that we can help to provide you insight at what voltage levels you might be. So if you can see, if I want to go ahead and jump to like 1.450, hey, you know, you can kind of keep in mind that that's an unsafe voltage that you should be at.
It's a bit high for this processor.
So versus where if I go, you know, back to the 1.275, you can still see that you're in a normal territory in terms of your CPU voltage. So we feel that we've really provided a strong level of value here, that visually you have the great same level of accessibility at controlling your system as you do within the UEFI environment, but you can do it now very simply and easily with the information, whether you want to key it in or whether you want to have that nice precision control as being able to adjust the slider. And of course, that's going to be applicable to other voltages as well. So if we go back to, let's say, the adaptive option, you can go ahead and you could drag that slider and you could see how that works as well. And you can see that you have that flexibility if you want to go that route. So it's really up to you in terms of how you wanted to define it.
Okay.
And you can just go ahead and click undo so we don't have to apply that. And if you want to scroll down there, you can see that, of course, we have a whole other range of all options available to you that can all be entirely tweaked and tuned, just like we have in previous generations. But we're going to maintain that ability to allow you to have that full manual entry control as well. So a really nice level of functionality that, of course, you can also save a profile for, so that you can always load that and take advantage of whatever configurations you're making real time. Now, we of course have the BCLK options that we have had previously, but we also now have the CPU strap option that's available to you as well. So that's what's new within this generation. We won't touch on that because that'll be in the overclocking section.
Okay.
But if you want to make an adjustment to it, you'll be able to do that. Now keep in mind that the strap cannot be changed real time though, so if you make an adjustment to it, it would force a reboot of the system to reset the CPU strap.
Okay. And CPU strap is going to affect just about all of your other settings.
Correct, because it will be linked in with not only the DRAM, but also the CPU voltages.
All right.
Excuse me, the CPU frequencies. So you can go over to the EPU section. And EPU, we've got a lot of cool options that we have in here. So we can do, if you see here, voltage reductions. And so the cool thing about that is that's actually how it applies a actual voltage downgrade, so that we can actually provide less voltage to the CPU to reduce power consumption and improve the idle thermals of the system as well. So that's a nice plus point. And you can see that there's advanced options that we have for power management that you normally have to kind of jump into Windows to be able to define. So we can more easily kind of adjust, you know, monitor value, how your system sleeps, and if you want to do never or not never, you want to do 15 minutes, 20 minutes, 1 hour, whatever it might be, you can quickly change all of those values. And at the same time, we can also go ahead and make configurations to our fan profile. Now this is under the auto assessment in terms of the configuration parameter, but there's going to be some other options that if we click into different values, we have more flexible points that link back to the original screen where we have different profile tabs. If you head over to the max power saving, you can even see that this is a cool option here where we have the configured max CPU. In previous generations we had a fixed power target where you can pick like 45 watts or like 35 watts. Under this generation platform, it's fully adjustable. If you want to be able to have your CPU drop down to as little as only taking 20 watts, then drop it down and there'll be a calibration button that will appear. You can click that calibration button and we'll automatically set the whole system so that the CPU doesn't consume more wattage than that. So it's a great way if maybe you're setting up a small centralized box, maybe for server functionality, you're buying maybe a different type of lower power, you know, Haswell oriented part, that you can even define the power characteristics for you. You know, this might be more focused for users that are maybe doing, you know, stock operation and looking for the best power flexibility specific to how they set up their system. But another really advanced type of level of control, but done in a very simple way where you just pick the wattage that you want to target in on, and we're going to do all that back end for you.
It's a great way to save some power.
Yeah. And if we jump over into the Digi Power Control options, of course, here we're able to go ahead and take advantage of all the key items that are enabled by the IVR and our external Digi Plus VRM technology. So we can make, of course, all real-time adjustments to you. So you guys that are familiar with AiSuite II know that we've had these for a while now. So it's a great just way of giving you all the same options you have inside the UEFI, but they're all real-time available to you within the operating system. You can tweak and tune those. And the IVR, which only has power management options for the CPU, we still maintain our digital design, which still gives us full power management options for the DRAM as well. So you're still going to be able to go ahead and tweak and tune VRM options specific for the DRAM because that is not controlled by the CPU.
And I like whenever you highlight one of these over on the right side, if you're not familiar with exactly what it is, you have a quick description of what you're actually going to be adjusting.
Yeah, so it just gives you a little bit more context to try to make it a little bit easier to work through, right?
All right.
And if we head over to Fan Expert 2, of course, that's the last module that we have as part of kind of the standard part where you have all your fan control functionality. You can switch the different fan headers. We can here go ahead and set the overriding profile for what the system might be at. So silent, standard, turbo, or even full speed, and it'll just go ahead and have all the FAD speeds ramp.
That works.
Yeah, and we can go ahead and set it back to maybe silent. And you can just, of course, scroll through each one of those. And if we go ahead and click into them, we have an ability to go ahead and configure them more specifically. So of course we can go ahead and set a full custom fan gradient if we want to, with a high degree of flexibility. And you can see, of course, it measured all that information so we know where the fan actually stops working in terms of what its minute operating value is. And here, this is where we're talking about fan spin up time, fan spin down time. So we can really even adjust how that fan is responding at each one of these points in the curve. So you can make it more aggressive or less aggressive at how it's ramping up and down.
And is that to help avoid that sudden whoosh of the fan ramping up really quickly?
Correct,
okay.
correct. And then lastly, sometimes you want the ability to maybe set a fixed RPM mode, right? So that's going to be that option, which is great for intakes. Maybe like your front intake fans, you don't want those to always vary, right? Maybe you want to fix them in at like, 900 or 1100 or 1200 RPM, just always being kind of soft, not really loud, but always bringing in airflow into your system. That's a really great option for fixed RPM, whereas maybe your back chassis fan, you want that to always respond to the temperature for the CPU and want that to be on a gradient where it could be silent, or you could also always have that fixed so that that's always helping to always exhaust out air, right? And maybe only your CPU fans are on a smart mode kind of adjustment or a gradient where they're always changing based on temperature values that you assign.
Nice. So pretty much any way you want to configure your fan, you have it available right there.
Yeah, an extensive level of control per each one of the headers. And the last part that we have is, of course, we still keep all the classic hallmark functions that provide a huge amount of value, which is going to be here. If we click over here, we have still other options where this isn't the complete portion of AiSuite 3, but if you were to click on this would have the other options such as USB 3 boost, our iNetwork control, USB BIOS flashback, all the other kind of modules that provide you additional benefits as part of our motherboard that require AiSuite 3. So as always, you've got a huge amount of flexibility and functionality available to you here.
Excellent. So that is a quick, well, maybe not quick, but very detailed overview of the AiSuite 3 software. And is there anything else that this can do that we haven't touched on yet?
It doesn't yet make you breakfast, but we're working on that.
Working on the breakfast thing. We do also, if you guys notice NFC right there, we're going to be doing a demo of that as well. If you guys are interested, check that out. But that's going to wrap it up for this video. So JJ, thank you once again for sharing all of this information with us.
As always, thank you for having me, Paul.
And thanks to you guys for watching. Of course, as mentioned, we have lots of coverage with JJ for the entire line of ASUS motherboards on the Z87 chipset. So check those out if you want to see more details on the motherboards themselves or the features, because it's all there for you. That's going to wrap it up for this video, though. I'm Paul with Newegg TV. We've been talking with JJ from ASUS. Don't forget to subscribe if you haven't already to our Newegg TV YouTube channel. Don't forget to like the video if you enjoyed all of this information, and we'll see you next time.